So it says we've got this direction, p is moving at this direction 4i plus 3j at time t equals 0. So at time t 0, 4i, so we know 4i represents the x axis. So that is 4, imagine that's 4i and that's 3j, that's the direction it's travelling at. Right? So it's really going in this motion, like this arrow here. Now using Pythagoras theorem, we know 4 squared plus 3 squared, and we square root that will give us the hypotenuse, which is 5, and we know that's a 3/4. So this is 5 here. Now as a key point is speed is different from velocity, so this might catch you out. So if speed equals 15 meters per second, therefore, so if you can see this is saying that the speed right now is 5, but it's saying it's 15. So the velocity must equal, because this 4i and 3j in this direction is worth 5, so the velocity must be 3 times the 4i plus 3j, because that actually makes the 15. So 3 lots of this will make the 15, because 3 lots of 5, which is then simplified to 12i plus 9j Right, does that bit make sense? And if you was to square these numbers and square root that, that will get the speed. Okay, perfect. So once we've got that, this is SUVAT, and in your mock exam, you could have used SUVAT to answer some questions. So S, we don't know, right? So we don't use that. But U, we have it as this 12i plus 9j. 12i plus 9j, sorry. Now V, now there is a V here, because it says here 6 seconds later P is moving in that direction, minus 12i plus 6j. A, well, this is what we want to find, so I'm going to put a question mark here. And T, well, it gives us the time, is 6. T equals 6. So what this question is essentially saying is, at time 0, P is moving in this direction, and 6 seconds later, you can see it's changed direction because we've got a minus 12i here. So we need to use a SUVAT equation that's got U, V, A and T, and hopefully you know which one to use, which will be V equals U plus AT. So we just substitute our values in, minus 12i plus 6j equals 12i plus 9j plus the 6a. Now we just rearrange that in terms of a, so we're going to get minus a 12, so that's minus 24i. Minus the 9j, which is minus 3j on this side, equals 6a. Divide out by 6, and we're going to get minus 4i minus a half j, and that's meters per second, to equals a. That's the acceleration. So 2, S, we don't have. U equals U in this case, because we're trying to find U. V equals minus 6i plus j. Now it gives us the acceleration as well. A equals 2i minus 5j. And we know T equals 3. So I'll just use v equals u plus at again. So we get minus 6i plus j equals u plus 3 times a. So I'm just going to write that answer in straight away. 6i minus 15j. And then we can resolve to find u. So we get u as minus 12i plus 16j equals u. And it says it has speed u. So this is technically the velocity of u as a unit vector. And then we just use Pythagoras theorem on this. So we just square root to get the speed. 12 squared plus 16 squared, which equals 20 meters per second, which equals u. So that's good. So you're just using those skills, the substitution of the SUVAT, which can be used in other types of questions as well. Okay. Question 3. Slightly different. Now, do you want to give that a go, or do you want me to go through it? And for those who aren't sure, you might be familiar with this. R equals R0, which is the original position, plus Vt. So that's the original position, plus its velocity times the time, which will give it its new position. That will really help you start it off. So that's I0, 4i minus 3j, that's where it's starting. At time r, well, that's where it ends up. And t equals 3. Right, good stuff on you. And we just substitute those in. So minus 5i plus 9j equals 4i minus 3j plus 3v. We just rearrange that to get minus 9i plus 12j equals 3v. So v must equal minus 3i plus 4j meters per second. And that should make sense, because if it starts at this time, after 3 seconds it's going to move to a new place with a velocity, and we get the new position it's in, which is r. That's a, and then b. T is now 5. RC, because the particle is p. I need to find that out. Now we still use R0, so that's 4i minus 3j plus 5 seconds, but we have v now, so we're still using the same formula essentially, but we have v now. That's our v from before. Expand that out. So I now you could make a mistake on this final part, find the distance from A to C, but its start point is A, its finish point is C. So we've got this. So I, the start point, is 4i minus 3j. And just so you know, RC is minus 11i plus 17j. And the distance, so we do need to use Pythagoras theorem, but let me see. So 4i minus 3j. So imagine on a graph, if that was 4i minus 3j as a coordinate, where would minus 11i plus 17j be? So imagine 11 minus 11i will be, just say somewhere here, and 17j is up here. Just so you can visualize it. So we've got to find the distance between these 2 points, right? So from here to here, if it goes from 4i to all the way to minus 11j, you should remember you minus the two distances. So that is actually a distance of 15 across, and up going from minus 3 to plus 17, because you go plus 3 to get to 0, then a plus another 17. So that bit has to be a triangle of 20. So we get this triangle, and that's A, and that's C. So we just use Pythagoras theorem there. So AC equals square root of 20 squared plus 15 squared, and that equals a nice 25 meters. Oh, not squared. So that should make sense. So I'm going to let you try question 4. And that should make sense. Let me know if it doesn't. Alright, so I'm going to move on to, and there's a different time and a different position. So we will be using R equals, the new position will be equal to the original position plus velocity times the time. Now from the wording of the question, you need to see that that is R. Because from the wording of the question, you can see the boat is at this position vector. And R0 must be this one. So, just because of time, I'm going to start going through it. Do you have to convert to seconds? Right. At 14:13 the boat is, that's at 2:30, and at point B you expect, yeah, well look at the question, if you've got T hours, so you might have to convert something later. So it's at noon, so T is essentially 2.5 hours, which is 2.5 hours, remember we have to use that. So let's just start this off. Minus 5j, add 2.5 times v, we rearrange that because we don't actually know what v is, to minus 10i plus 15j equals 2.5 v. So v equals minus 4i plus 6j, but the time was in hours, so I would leave the time in hours, meters. So that's not meters per second, that's meters per hour. So just mph. And it just says find the velocity of b, so I'll just leave it like that. Mark scheme says meters per second, but that it's not in meters per second because time's in hours. B, find the bearing of the velocity vector. So that velocity vector is going like this, going this way, minus 4i and 6j. Right, and you could make a mistake with this. First I'd find this angle, so that's 6 here. That's 6j there. And then, you know, tan theta equals opposite over adjacent, so that equals 6 over 4. So theta equals 56, probably rounded. Now, let's draw that here. If this is 56, remember bearings is from north, isn't it? So we have to go all the way round like that. So you can see the bearing is in fact 270 plus 56, which equals 326. Bearing must be in 3 digits. So that's part B. Okay, well done on you. So you strong at this, so we can do integration acceleration next week. I think you'll be ready for, which came up in your mock, didn't it? Can't remember what question it was. So part C, find an expression in terms of t for the position of B t hours after noon. So that's clearly we have to do it in hours. So that just means create like a formula in terms of but we need to start off with this formula. But expression is just having terms in it and no equal sign. So we're just using that same one here. We know R0 is 2i minus 5j, and r is the position. We just need r, v and t. Now our v is minus 4i plus 6j. It says find the value of t. Oh, sorry, one question. In terms of t, so we don't need to know t. T equals t. Let's just substitute that all in. R equals 2i minus 5j plus t times r minus 4i plus 6j. And j's, what do you say? Find expression in terms of t. In terms of t, so if we expand that all out, we're going to get minus 4it plus 6jt. So we want to write these together as one. So that is actually 2 minus 4t. Now we can put the I on the outside. Plus 6t minus 5j, and that's the expression for the new position r. And understanding these skills will help you do the more difficult questions.